So in this case, we are going to continue from what we had now. We want to solve simultaneous linear equations on our matrices. Remember, we referred back working with the inverse, all right, from the inverse matrix and some properties that can happen if we are dealing with an inverse, multiplying an inverse to the original matrix, giving us an identity matrix. So when you are to solve simultaneous linear equations, you apply that concept, all right? So I'm just going to show you the steps that you can take in solving these linear equations. Let's say you're given 3x minus 2y is equal to 14, and another one is given as minus 5x plus y is equal to 0, like this. We have got two equations, linear, simultaneous. All right. So in order for you to solve, you rearrange or rewrite into matrix form. This equation you express in matrix form. That's the first thing you have to express in what? Matrix form. How do you express it in matrix form? All right. You take the coefficients, the part of x, you must have this in this format. Ax plus by is equal to c. So then another one, all right, so let's consider A, B, C, D. Then we have got dx, all right, E, and this is F. So if we are given this, you consider the part of X, this one, the variables, this part of X, all right? What are the coefficients? You take them in what? In matrix form, A and D. So you take A, D, okay? Here, B and what? B and E. The coefficients for what? The variable Y. So B and what? B and E in matrix form. Then that X and Y, you write it as a column. Equate it to CF as a column again. So this is how you express in matrix form. So you consider the coefficients for the what? The given variables. The variable X, the coefficient is what? 3. The variable X here, the coefficient is what? Is 5. So I can rewrite as 3 minus 5. Then let's move on to Y. Y here there's -2. Here it is positive. Positive what? The number that is not represented there, that is not shown there, I mean, is what? Is a 1. If the number is not shown, it simply means there is a what? A 1. So you consider the number and the what? The sign. So this is what? -2, and a positive one, just write 1 as it is, all right? So this is from the coefficients of what? These variables. Then you take those variables as a column, X and what? X and Y as a column. Then that's equal to 14, 0, just like C and F here. 14 and what? And 0 as a column. So the first thing is the order. You must have the order in this manner. The X first followed by Y to the what? To the constants. To the constants. All right. So must be very careful. X, Y, then constants. So if it is not given that manner, you have to rearrange to express it in this manner. All right. After that, you determine the determinant of the 2 by 2 matrix, actually the inverse. You find the inverse of that 2 by 2 matrix. So let's say this one, it is matrix A. You find its inverse, right? So you're going to find the inverse. The inverse of what? Of the 2 by 2 matrix. The inverse of the 2 by 2 matrix, and multiply by 8 both sides. both sides of our equation, of this equation. So the 2 by 2 matrix is this one. This is your 2 by 2 matrix. So you find its inverse. 3 minus 2 minus 5, 1. Its inverse, we know that you're going to need the determinant first, as we saw previously on the calculation of the determinant. What we are going to need is what? On the calculation of the inverse, we are going to need the determinant. Then that part follows of swapping major diagonal, multiplying by negative in the minor diagonal. But first, it is what? The determinant. So the determinant, the product of what? The major diagonal, 3 and what? 3 and 1. 3 times 1 minus the product of what? The minor diagonal, which is minus 2 versus what? Minus 2 versus minus 5. Minus 2 times minus 5. So that was going to give us the determinant. 3 times 1, that is 3, minus 2 and minus 5, negative to a negative, that's what? A positive. So minus 2 times 5, that's a positive 10. So subtract, that is going to give us what? A negative what? A negative 7. So this is what you're going to have as the determinant. So therefore, the inverse now is going to be 1 over determinant, 1 over minus 7. So it is minus 1 over 7, all right? What happens from that 1 over determinant? You swap the what? What was in the major diagonal. So what was in the major diagonal, you swap them. So you simply swap, that's 1 here and 3 here. Then the minor diagonal, you multiply by what? By a negative, the minor diagonal. So negative times negative 2, that's a positive 2. Negative times negative 5, that's a positive 5. So this is our inverse, which you can write or leave it as it is like this. As what? As it is. That's your inverse. But I said here, you find the inverse of the 2 by 2 matrix and multiply by it both sides. So this is our inverse of the 2 by 2 matrix. So we're going to multiply it both sides. Minus 1 over 7. All right. 1, 5, 2, 3. This is our inverse. It multiplies what was on the what? On the left side of our equation. 3 minus 2 minus 5, 1. As it is, it multiplies as it is, all right? The same inverse, because it is both sides, so you have to consider on the other side of the equation, the same inverse multiplies that side of the equation. Minus 1 over 7, all right? 1, 2, 5, 3. So this is what you're going times what? 14, 0, like that. What was on the what? What was on the right-hand side already? The 14, 0. So this is the concept. The inverse, you multiply both sides of your equations. But now, because of what we stated before, guys, about this inverse in its multiplication, when an inverse is multiplying its original matrix, you obtain what? Identity matrix. Remember, we proved even here. We proved it. So here, this is what is happening, guys. This is the inverse here of a matrix that is the same as the inverse of A. From both, it was calculated from this matrix. So let's say this is our matrix A. When the inverse of A multiplies matrix A, what happens? You obtain an identity matrix. So from the product of this on the left-hand side, you are going to obtain what? An identity matrix. It is not something that is coming from nowhere. It's something that was mathematically proven. We talked about this here. We proved it mathematically by calculation. So it's not a magic here. It's a calculation that was made. Then the xy is on this matrix. So we are going to take it back, xy. So here we just applied the first two, the inverse and its original matrix. So that was it. So this is equal to, on the right-hand side now, be careful because on the right-hand side, the inverse that we calculated was of the 2 by 2 matrix. It was not from the right-hand side. This inverse that we calculated, it was not from 14,0, no. So we are not going to use that to say the inverse terms. No, this is not the original matrix where the inverse was taken from. So here you perform exact multiplication, do proper multiplication there, right? Minus 1 over 7, you multiply properly row by column concept. Yes, proper multiplication, row by column. So let's multiply 1 times 14, that's 14 plus 2 times 0, that's a 0. Remember, a 2 by 2 can multiply what? A 2 by 1, and our answer is going to be a 2 by 1. All right, so 1 and 14. Then after that, this row and that column again. So that's 5 is going to multiply 14, which is what? 70. 5 times 14, that's 70. 3 times 0, that's what? That's a 0. So this is it. All right, this is where we are. Let us consider again, simplify. Now it's just simplification from here, just simplification. Remember again, the inverse that multiplied this and obtained identity. What I talked about, this identity matrix. Identity matrix in numbers, it is just same as represented by 1. 1 times any number, you obtain that number. So identity matrix in matrices, you just apply or use it as 1. So this identity matrix, when it multiplies xy, the answer is going to remain as what? As xy. Identity matrix times any matrix, you obtain that matrix, all right? Remember what I said before. So meaning to say, that is what you're going to have here. So the only simplification is on the what? On the right-hand side. So that was going to be minus 1 over 7. You add here 14 plus 0, that's 14. 70 plus 0, that's what? 70. Then simplifying the right-hand side to obtain the value of x and y is going to be minus 1 over 7 times 14, because this is just a scalar. So it multiplies what? The 14. So that's 2 times negative 1. That's negative 2. The minus 1 over 7 multiplies the what? The 70. The 70. So the 7 into 70, 10 times negative 1, which is what? Negative 10. So this is what we have. So we know that there is no way, guys, we have this same order. So it simply tells us that these corresponding elements are exactly the same. So therefore, x is what? X is equal to minus 2, and y is equal to what? And y is equal to a negative 10. So you can use this in solving simultaneous equations using what? The matrix method, using this idea. Like I said, make sure that the order is in this manner: ax plus by is in this, starting with x followed by y to the constant x, y constant. If not in that manner, rearrange your equations. Please rearrange your equations. So that is basically what you're going to have as part of matrices. We talked about this. So this is the last part that we're going to have on our matrices, which is the use of the inverse matrix in solving simultaneous linear equations. So if there is any question that we're going to have, it's going to be revision, question papers, any revision, any question that you do not understand, the comment section, that's the purpose of it. Let's communicate on the comment section or the community section. Send your questions there, all right? Let's utilize everything there on the platform, all right? Let's utilize the platform that we have to send our questions. Send your questions through the what? The community section, the community tab. all right, on your YouTube. If you check the YouTube tab, there is the community tab. There you can send, you can post as well on my channel, on this channel, Medzone African Motives. You can post your own information, all right? Questions, you can even take pictures and post the questions there. So utilize that, all right? Utilize that community tab, all right? Because the comment section is limited. You can say, okay, I want to do this, but for a specific question, there is no need of, I want the WhatsApp number, I want this. The community tab is the one. There you communicate as you are communicating on WhatsApp. You send your question there. You can take a picture. You can communicate whatever that you want. So let us communicate there so that we have revisions properly on the channel, all right? So that I do not work with WhatsApp. I have to visit WhatsApp to check what are you looking for. Then I back to the YouTube. Let me finish everything on YouTube. If I just say I'm entering there just to check what is happening, then the community tab, I'm supposed to see your comments, your comments there, or what you have posted. You can post from your side where you are on this channel. So this is what I want you to do so that you participate on the channel, be part of the channel as it is your channel. So that is it, guys. Till we meet again.